So which way will electrons flow? Thinking about this more, under standard conditions, zinc has a stronger tendency to oxidize than copper. Copper has a less strong tendency to oxidize. So in this case, if we have an anode with Cu going to zinc, so if we have Cu oxidizing, that is actually at a lower, the electrons are at a lower potential energy in the copper. And so it's actually non-spontaneous. You'd have to go up in potential energy to oxidize copper and reduce H2 gas. So the oxidation of copper from a copper solid metal to Cu2 plus has a negative electron potential. It doesn't want to happen. In this particular case, then E final, as it's written there, E final is the hydrogen reduction, minus E initial, that is the copper oxidation, is going to be minus. It doesn't want to happen. You have a non-spontaneous reaction with the electrons going from copper, where they're relatively happy, to move on to the H2. So this is a non-spontaneous reaction. It has a cell potential of minus 0.34. Okay, so a very important chart here is the standard electrode potentials, and we're going to be using this for most of the next few segments. You can find more than these, but this is a relatively complete chart. On this page, we have everything that has a higher tendency towards reduction, that has a positive standard potential. Compared to hydrogen. The top one on here is the hydrogen reduction to H2, so that they're listed as reduction potentials. You can flip them all around and they'd be oxidation potentials. So we can see, for example, that fluorine has a very high tendency towards reduction. Makes sense. We know that F minus is pretty stable, that fluorine is pretty electronegative, and that lithium is quite really would like to lose that electron compared to hydrogen. Again, these are not in absolute terms. These are compared to the hydrogen potential. A lithium is very likely to give up. The electron is highly likely to be oxidized. Yeah. You can see things that you'd expect, like all of the group 1, group 2 metals are down, being very likely to be oxidized, and things like the halogens and things in relatively high oxidation states like to be reduced. Okay. So yeah, we'll be coming back to this quite a lot. So some tendencies from this table. The higher on the table of standard reduction potentials, the stronger tendency for the reaction to be reduced, i.e. things like halogens, things like the highly oxidized compounds like permanganates, perchlorates. Lower on the table of standard reduction potentials, the stronger tendency for the product to be oxidized, like sodium, potassium, group 1, group 2 metals.